Today we are going to discuss the paper Direct Preference Optimization. Your language model is secretly a reward model. This paper introduces a new method for aligning language models with human preferences without using reinforcement learning. The key idea is that existing methods like reinforcement learning from human feedback (RLHF) require training a reward model and then optimizing a language model using reinforcement learning, which is computationally expensive and unstable. Instead, this paper proposes direct preference optimization (DPO), which reformulates the problem in a way that allows for direct optimization using a simple classification loss. The main problem the paper addresses is the complexity and instability of RLHF. Reinforcement learning methods like proximal policy optimization (PPO) require multiple models, sampling during training, and extensive hyperparameter tuning. This makes them hard to implement and computationally expensive. DPO eliminates these issues by leveraging a different way of defining reward models. Instead of explicitly learning a reward function, it learns a policy directly from human preferences. This means that we no longer need to sample from the model during training, significantly simplifying the process. So how does it work? The key insight is that in RLHF, the optimal policy can actually be derived in closed form if we assume a certain structure of the reward model. Specifically, the paper shows that the reward function can be rewritten in terms of the optimal policy itself. This allows the optimization to be done using a simple cross-entropy loss rather than reinforcement learning. This reformulation means that DPO avoids the instability of RL algorithms while still achieving the same or better alignment with human preferences. In practical terms, the DPO algorithm takes a dataset of human preferences where people have chosen preferred and non-preferred responses for a given prompt. Instead of first training a reward model and then optimizing a language model with RL, DPO directly optimizes the language model so that it assigns higher probability to the preferred response and lower probability to the non-preferred response. This is done in a way that preserves the original distribution of the language model, avoiding the problem of the model deviating too much from its original state, a major challenge in RLHF. The results show that DPO outperforms PPO-based RLHF in multiple tasks, including summarization and dialogue generation. It achieves higher quality outputs while requiring significantly less computational effort. Importantly, it also provides a better trade-off between optimizing for human preferences and maintaining fluency and diversity in language generation. Another key advantage is that DPO is much more stable than PPO, which often suffers from high variance and reward over-optimization issues. However, while DPO simplifies preference optimization, it does not solve all problems. One limitation is that it relies on good quality preference data. If the human labels are noisy or biased, the model will learn those biases. Additionally, while DPO improves efficiency, its performance in large-scale settings, such as training massive models like GPT-4, remains an open question. To summarize, DPO presents a fundamental shift in how we align language models with human preferences. By eliminating the need for reinforcement learning, it makes preference learning much simpler, more stable, and more efficient, while maintaining or improving performance. This makes it a highly practical alternative to RLHF and a major step forward in making AI systems safer and more controllable.